A software development lifecycle model describes the types of activity performed at each stage in a software development project, and how the activities relate to one another logically and chronologically. There are a number of different software development lifecycle models, each of which requires different approaches to testing. Software development and software testing. It is an important part of a tester's role to be familiar with the common software development lifecycle models so that appropriate test activities can take place. In any software development lifecycle model, there are several characteristics of good testing. 1. For every development activity, there is a corresponding test activity. 2. Each test level has test objectives specific to that level. 3. Test analysis and design for a given test level begin during the corresponding development activity. 4. Testers participate in discussions to define and refine requirements in design, and are involved in reviewing work products, e.g., requirements, design, user stories, etc., as soon as drafts are available. No matter which software development lifecycle model is chosen, test activities should start in the early stages of the lifecycle, adhering to the testing principle of early testing. This syllabus categorizes common software development lifecycle models as follows. 1. Sequential development models. 2. Iterative and incremental development models. A sequential development model describes the software development process as a linear, sequential flow of activities. This means that any phase in the development process should begin when the previous phase is complete. In theory, there is no overlap of phases, but in practice, it is beneficial to have early feedback from the following phase. In the Waterfall model, the development activities, e.g., requirements analysis, design, coding, testing, are completed one after another. In this model, test activities only occur after all other development activities have been completed. Unlike the Waterfall model, the V model integrates the test process throughout the development process, implementing the principle of early testing. Further, the V model includes test levels associated with each corresponding development phase, which further supports early testing. In this model, the execution of tests associated with each test level proceeds sequentially, but in some cases overlapping occurs. Sequential development models deliver software that contains the complete set of features, but typically require months or years for delivery to stakeholders and users. Incremental development involves establishing requirements, designing, building, and testing a system in pieces, which means that the software's features grow incrementally. The size of these feature increments varies, with some methods having larger pieces and some smaller pieces. The feature increments can be as small as a single change to a user interface screen or new query option. Iterative development occurs when groups of features are specified, designed, built, and tested together in a series of cycles, often of a fixed duration. Iterations may involve changes to features developed in earlier iterations, along with changes in project scope. Each iteration delivers working software which is a growing subset of the overall set of features until the final software is delivered or development is stopped. Examples include 1. Rational unified process. Each iteration tends to be relatively long, e.g., 2 to 3 months, and the feature increments are correspondingly large, such as 2 or 3 groups of related features. 2. Scrum. Each iteration tends to be relatively short, e.g., hours, days, or a few weeks, and the feature increments are correspondingly small, such as a few enhancements and/or 2 or 3 new features. 3. Kanban. Implemented with or without fixed-length iterations, which can deliver either a single enhancement or feature upon completion, or can group features together to release at once. 4. Spiral. Involves creating experimental increments, some of which may be heavily reworked or even abandoned in subsequent development work. Components or systems developed using these methods often involve overlapping and iterating test levels throughout development. Ideally, each feature is tested at several test levels as it moves towards delivery. In some cases, teams use continuous delivery or continuous deployment, both of which involve significant automation of multiple test levels as part of their delivery pipelines. Many development efforts using these methods also include the concept of self-organizing teams, which can change the way testing work is organized as well as the relationship between testers and developers. These methods form a growing system, which may be released to end users on a feature-by-feature basis, on an iteration-by-iteration basis, or in a more traditional major release fashion. Regardless of whether the software increments are released to end users, regression testing is increasingly important as the system grows. In contrast to sequential models, iterative and incremental models may deliver usable software in weeks or even days, but may only deliver the complete set of requirements product over a period of months or even years. Software development lifecycle models in context. Software development lifecycle models must be selected and adapted to the context of project and product characteristics. An appropriate software development lifecycle model should be selected and adapted based on the project goal, the type of product being developed, business priorities, e.g., time to market, and identified product and project risks. For example, the development and testing of a minor internal administrative system should differ from the development and testing of a safety-critical system such as an automobile's brake control system. As another example, in some cases organizational and cultural issues may inhibit communication between team members, which can impede iterative development. Depending on the context of the project, it may be necessary to combine or reorganize test levels and/or test activities. For example, for the integration of a commercial off-the-shelf (COTS) software product into a larger system, the purchaser may perform interoperability testing at the system integration test level, e.g., integration to the infrastructure and other systems, and at the acceptance test level, functional and non-functional, along with user acceptance testing and operational acceptance testing. In addition, software development lifecycle models themselves may be combined. For example, a V model may be used for the development and testing of the back-end systems and their integrations, while an agile development model may be used to develop and test the front-end user interface, UI, and functionality. Prototyping may be used early in a project, with an incremental development model adopted once the experimental phase is complete. Internet of Things, IoT, systems, which consist of many different objects, such as devices, products, and services, typically apply separate software development lifecycle models for each object. This presents a particular challenge for the development of Internet of Things system versions. Additionally, the software development lifecycle of such objects places stronger emphasis on the later phases of the software development lifecycle after they have been introduced to operational use, e.g., operate, update, and decommission phases. Reasons why software development models must be adapted to the context of project and product characteristics can be: 1. Difference in product risks of systems, complex or simple project. 2. Many business units can be part of a project or program, combination of sequential and agile development. 3. Short time to deliver a product to the market, merge of test levels and/or integration of test types in test levels.